So we'll discuss the fourth question now. This is the fourth question, and again here we have is a circuit involving some resistors and a dependent source, a voltage dependent voltage source 4Vx, which is dependent on the voltage drop across this 5 ohm resistor, and we have been asked to find the Thevenin equivalent circuit, that is VTh and RTh. Okay, so here as you can see there are no independent sources present, voltage or current. So when there are no independent voltage or current sources present in the circuit, it means VTh, Thevenin voltage, is equal to 0 volt. We have already discussed a question related to that. VTh is 0 volt. So only thing that is remaining here is calculation of RTh. Okay, so we'll be calculating RTh. So here there are no independent voltage and current sources, so no need to deactivate anything, short circuiting or open circuiting. So here what we'll do, we will excite the circuit with our own independent source. So let us connect a 1 volt voltage source and let us find the current supplied by it. Then RTh will be 1 volt by I0 in ampere or whatever be ohm. RTh will be this 1 volt by I0. So our main objective here is to find I0. Okay, so we'll be using mesh analysis. So for that we have to assign the mesh currents to these two meshes. So let us assign the mesh currents. Let this be I1 and let's say this is I2, clockwise and anti-clockwise directions. So here an important relationship is I0 is equal to I2, they are in the same direction. This is equation number 2. This is, that is RTh is 1 volt by I0, that is equation number 1. Okay, let us consider this as 1 and this is 2. Okay, so let us erase this one. Okay, another thing is this Vx. Here the voltage drop across the 5 ohm resistor, that is Vx. The current is flowing upwards, so the actual polarity will be in this way, plus minus, but Vx, the polarity is asked in this way here, Vx, but current is flowing in the opposite polarity. So Vx here will be minus 5 I1. Vx will be minus 5 I1. That is also an important relationship here, minus 5 I1. Okay, so 3 relationships we got. Now we have to write the mesh equations. So for the first mesh it is minus 5 I1 minus 10 I1 minus 4 Vx. Minus 4 Vx means, well, let us write first minus 4 Vx, then minus 15 into I1 plus I2 equals to 0. I1 and I2 are both flowing downwards through this 15 ohm resistor in the same direction. So I1 plus I2, they are in the same direction, I1 plus I2. I1 is flowing downwards, I2 is also flowing downwards. So now replacing Vx with minus 5 I1, it will be minus 5 I1, that is minus 15 I1, let's say this is minus 5 minus 10 minus 4 into Vx is minus 5 I1 minus 15 I1 minus 15 I2 is equal to 0. That implies minus 15 I1 plus 20 I1 minus 15 I1 minus 15 I2 is equal to 0. That implies minus 15 is minus 30 I1 plus 20 I1 is minus 10 I1. Minus 10 I1 minus 15 I2 is equal to 0, or 10 I1 plus 15 I2 is equal to 0. Or if we take 5 common, it will be 2 I1 plus 3 I2 is equal to 0. This is equation number 4 for the first mesh. So let us write it down here. 2 I1 plus 3 I2 equal to 0. Now we will write the mesh equation for this second mesh. Okay, so let us do that. So here the mesh equation will be, for the second mesh going in from this side, 1 minus 15 into I1 plus I2, both flowing the same direction, is equal to 0. That implies 15 into I1 plus I2 is equal to 1, or 15 I1 plus 15 I2 is equal to 1. Okay, so now here we have got the two equations. This is equation number 5. 15 I1 plus 15 I2 is equal to 1. Now all you have to do is solve them. Okay, so we have got all the equations. So here we have the two equations, the two mesh equations. Now we have to solve them. So one way to solve it is, let us multiply minus 5 with this first equation. Minus 5 will multiply. Then it will become minus 10 I1 minus 15 I2 is equal to 0. If we add this with this, 15 I1 plus 15 I2 is equal to 1, then this will get cancelled. We will get 5 I1 is equal to 1, or that implies I1 is equal to 1 by 5 ampere. I1 is equal to 1 by 5 ampere, or we can say I2 from this equation, 2 I1 plus 3 I2 is equal to 0. We have to find I2 because I0 is related to that. I0 is I2, then that's our main objective. So we have to find a relationship between I1 and I2. So from this equation, 2 I1 plus 3 I2 is equal to 0. I2 is equal to minus 2 by 3 I1. I2 is equal to minus 2 by 3 I1. 2 by 3 I1, which is equal to minus 2 by 3 to 1 by 5, which is equal to minus 2 by 15 ampere. 2 by 15 ampere, which is equal to I0. I2 is same as I0. So all these equations we have written for a reason, because they tell us the interrelationship between various circuit elements, parameters that are involved here. So we found the value of I2, which is minus 2 by 15 ampere, which is I0. So RTH now is 1 volt by I0, which is 1 by minus 2 by 15, which is equal to 15 by 2, which is nothing but minus 7.5 ohm. So again, negative resistance. So negative resistance means the dependent source here is supplying power, because resistors can never supply power, they only absorb power. I have already, such a situation also was there in the previous question. I think negative resistance came. So negative resistance means that the dependent source, it is supplying power, because resistors can never supply power, they only absorb power. Okay, like this, current always flows in this way through a resistor. Voltage drop is plus IR, it can never be negative. Okay, so resistors are always positive, they always absorb power, they can never be negative. It means that the dependent source here, that is supplying power. So this is the fourth question related to Thevenin theorem application to circuits involving dependent sources. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.